Hello and welcome back to Solving Trigonometric Equations, Lesson 1D. So we're going to have a look at example 4. So this is where it gets a little bit trickier because there's one extra thing at the end to consider. So we're going to solve 3 cos 2x minus 120 equals 2. So again, let's just have a look at what we're doing there. So there's the graph of 3 cos 2x minus 120. We're just looking between 0 and 360, but just a reminder that we can go further along or further back. These cosines graphs are infinitely long, they go on forever and ever. So there's the 4 values that we're looking at, and we'd also have some values just outside the domain, the range of values of x. It's the domain, remember guys? Some values just outside 360 there. So why is it not starting at 0, 3? That's because we have 2x minus 120 here, which is going to give a shift to the right. So hopefully one or two of you are thinking, would it not move 120 degrees to the right? Because it doesn't appear to have gone that far, because it's only gone 60 degrees to the right. So remember, if we're doing this, work from the functions and graphs chapter, remember, if we're doing that, we actually need to take out a common factor of 2 there to find out the shift. So that's why it's only moving 60 degrees along. So cos of 2x minus 120 is just the same as the cos of 2 bracket x minus 60. So that's why it's only moving 60 degrees to the right there. Always worth mentioning that to remind you. Okay, right, so back to solving the equation. So basically we're looking for these 4 values, so we can have a look and see what we should be getting. So 35.9, 84.1, and so on. So back to solving it algebraically. So make cos of bracket the subject, and then find the inverse cosine of 2/3. So again, that's just how a National 5 work. So we're using the ASTC diagram here. So as we have a cosine and it is a positive value, we're looking in the first and the fourth quadrants. So it'll be the angle that we've calculated and also 360 minus that angle. So we'll have 48.2 and 311.8. Now, again, because it's 2x minus 120, we are looking for twice as many values as usual. Again, why is that happening? Because the cosine curve, as it's 2x, has been compressed by a factor of 2. So between 0 and 360, there's going to be twice as many points where the line cuts the cosine curve here. Twice as many points where that cosine curve is at a height of 2. So we can see the first 2 there, and then the next 2 afterwards. So to generate those extra values, we need to add on 360 degrees to each of the 2 solutions that we have. So 48.2 plus 360, 311.8 plus 360. Okay, so that's going to leave us with 2x minus 120, which is what was in the bracket here, equals all 4 of those values. So again, I've got an extra 2 there because it's 2x, it's going to be twice as many values, twice as many solutions. Now I need to add 120 to both sides of the equation here. So all 4 of these solutions I need to add 120 to. And then we've got 2x now, but I don't want to find out what 2x is. I want to find out what x is. I want to divide every single solution I have by 2. Now what happens here is that this value is beyond 360 degrees. So that's out of the domain 0 to 360. See how much time I've got left. So it's out of the domain 0 to 360. So what's happened here is that we've actually calculated this value. So because the graph has been moved along to the right, let's just have a look at what the original graph would have looked like before that horizontal transformation. So there's the value I've calculated. So I've actually calculated this value and then it's moved to the right by 60 degrees. So to get the value we're actually looking for, I need to jump back. We need to jump back 360 degrees from here, which will give me that value. So originally this value was here, but by pushing it to the right by 60 degrees, it's come into the domain of 0 to 360. So that is how we would find that extra value.